Hey everyone, thanks for checking out today's tutorial on subtracting rational numbers. For this section, we are going to follow the same rules for subtracting rational numbers as we did for integers. So if you remember those rules that we talked about, that was the chop method that I kind of call it for short, where we change the subtraction to addition and the next number to its opposite. And that's kind of this great meme up here too that I think is just hilarious. It says, when subtracting integers don't have a fit, leave the first one alone and add the opposite. Kind of corny, but I love the ostrich with the teeth here. I think it's hilarious. So we're going to follow the same rules we followed last section for integers, except now we're just introducing rational numbers. So numbers that create a ratio or a comparison like fractions or decimals. Okay, and you'll see that example here. Originally we had 2/5 minus -1/5, and they changed the subtraction to addition and the next to its opposite. So subtracting a negative is the same as adding a positive. And you can see then they just followed their fraction rules. Common denominator, keep it, add the numerators to get 3/5. So use those rules that we talked about in chapter 11 or the previous chapter. All right, so let's try one and make sure we can remember how to do that. Number one says -4 1/7 minus -6/7. So the first thing I'm going to do is I'm going to change my subtraction to addition and the next sign to its opposite. So I have -4 1/7 plus +6/7. I'm going to check and I'm going to do some estimating to make sure that this is reasonable. -4 1/7 is about -4 plus 6/7, that's almost 1. And -4 plus 1 would be -3. So my answer should be close to -3. Let's actually do the problem here and see what we come up with and see if it's reasonable. Okay. So when I add these two together now, I'm going to change my mixed number into an improper fraction. So 4 times 7 would be 28, plus 1 is 29. So this is the same as -29/7. Notice I kept my negative sign in my numerator, plus 6/7. Okay. Well, 7 and 7, I have a common denominator. I'll keep that. And then I have -29 plus 6. So notice here, now they have different signs. I'll find the difference. So what's 29 minus 6? 29 minus 6 would be 23. And then I need to think about, do I have a negative or positive? Well, -29 is a bigger absolute value, so I'll take the negative sign. Right? If that's tricky for you, think about it in a number line. If this was -29, this would be -30, this would be -28, -27, right? We start at -29 and we add 6 to it. So when we add, we go to the right. So 1, 2, 3. You can see we're getting closer to that -23. Okay. So -23/7. I have a negative divided by a positive. I know my answer is going to be negative. How many times does 7 go into 23? 3 whole times, which is 21. I'd have 2 left over to get to 23 and keep my denominator of 7. So I wind up at -3 2/7. And is that close to what I estimated at -3? And yeah, that's really close. So my answer is definitely reasonable. Okay. Let's try another example with decimals. It says find 12.8 minus 21.6. Okay, so if I wanted to, I could think about this as 12.8 plus negative 21.6, right? I just chopped here, chop. Change the subtraction to addition and the next to its opposite. You could think about it this way if you wanted to. I actually just like to think about it as a subtraction problem. 12.8 minus 21.6. And the method I'm going to use here is I'm going to think about elementary math. Meaning, in elementary school, I could not subtract 12.8 minus 21.6. You'd look at your teacher and you'd say, can't do that. My first number is smaller. So therefore, I know I need to have a negative answer. And then I just take and find the difference between 21.6 and 12.8. I'll just subtract those two, right? So got to borrow, make this a 0, make this 16. 16 minus 8 is 8. Bring my decimal down. And 20 minus 12 is 8. So the difference between 21.6 and 12.8 is 8.8. And I know since I'm subtracting my smaller number minus my bigger number, it needs to be negative. Negative 8.8. Okay. And again, you can check to see, is that reasonable? This rounds to 13 minus this rounds to 22. What's the difference between 13 and 22? 9. And this would be negative 9 since 13 is first. Is my answer close to negative 9? And absolutely it is. So it's reasonable. Alrighty. Please pause the video. Take 5-ish minutes here, maybe a little more, and go through these problems. Show your work. I left a little space here for you to really practice them. It's going to do you no good if you don't pause here and you just write down the answers. Pause the video, go through them, and then we'll come back to see how you did. Right, number 1, chop. 1/3 plus 1/3, 2/3. Number 2, leave the first one alone. Subtraction to addition next to its opposite. So I'm adding 2 negative numbers. I know it's going to become more negative. So negative 4 and 1/6 is what you should arrive at. Next one, 4.5 minus 5 and 1/4 be negative 3/4. Subtraction to addition next to its opposite. Adding 2 negatives, it's becoming more negative. So you just add these two, negative 15.1. Chop. And notice that we are adding opposites. Anytime you add opposites, you get 0. And lastly, again, chop. This just becomes a simple addition problem. You would wind up with 0.48 or 48 hundredths. Let me know if you would like any help on any of these, and I'll gladly go over them with you. Okay, we have 2 examples left to go through. And number 3 asks us to find the distance between 2 numbers on a number line. So there are a couple of different ways that you could go about doing this. I'll kind of show you the way that I like to think about it. And then we'll go from there. All right, so we're trying to find the distance between these 2 points. Let's just, for kicks and giggles, let's just say that we're dealing with whole numbers. And I'll just kind of show what I'm talking about in whole numbers. Say I wanted to find the distance between negative 3 and 2. How would I do that? Well, what I would do is I know that negative 3 is 3 away from 0, and then I still have to go 2 more. So I would say that distance is 5, right, if I'm dealing with whole numbers. I'm going to do the same thing, but just with fractions. So I know from negative 2 and 2/3 to 0, that distance is 2 and 2/3 away. You could think of it same as you think about absolute value. What's the absolute value of negative 2 and 2/3? Well, the absolute value means what's the distance between that number and 0? Well, it's 2 2/3 away from 0. Plus, how much further do I have to go to get to this number? Well, I have to go 2 1/3 to get to my end result. So I'm just adding then. Well, I know 2/3 and 1/3 give me 1 whole, plus 2 and 2 give me 4, plus this 1 whole would give me 5. And that's kind of the method I'm using to find the distance between two numbers on a number line. The other way that you can do that is you can actually find the difference of the numbers. So if you wanted to, you could write it out like this. You could say negative 2 2/3 minus 2 1/3. But if you'd chop here, you'd wind up with negative 5. And we're talking about the absolute value here. How far are the numbers apart? So it would just end up at positive 5. So you can think about it in a couple different ways. I like to just do this method right here to see how far from 0 are we, and then how far do we have yet to go, and add my two numbers. Hopefully that makes sense. Let's go on to the next example where it says, in the water, the bottom half of a boat is 2.1 feet below the surface, and the top of the boat is 8.7 feet above it. Towed on a trailer, the bottom of the boat is 1.3 feet above the ground. Can the boat and trailer pass under this bridge? All right. Kind of wordy, if you ask me. Anytime I see a wordy problem, I like to draw pictures. So let's do that. In the water, the bottom of the boat is 2.1 feet below the surface. All right. Here's what I'm going to do. Draw myself a sweet boat. Here's my sail. Okay, let's mark some water. And I know that the bottom of the boat is 2.1 feet below the surface. Okay. So that's 2.1 feet between the surface and the bottom of the boat. And the top of the boat is 8.7 feet above it. Well, you can tell my picture isn't a very good representation. Maybe I should draw my boat a little bit better here. Maybe we've got like a sweet yacht or something. It's a good thing I'm not an artist. Now my flag's going to be small. Okay, we know this distance. The top of the boat is 8.7 feet above the water. So if I know that it's from the top to the water is 8.7 and from the water to the bottom is 2.1, what's the height of my boat? Well, it would just be these two numbers added together, which would give me 10.8. And let's see, that's feet, right? Okay. Then it says, towed on a trailer, the bottom of the boat is 1.3 feet above the ground. Okay. Now we've got a trailer here. And now it says the bottom of the boat is 1.3 feet above the ground. Okay, so here's our boat. Bottom of the boat is 1.3 feet above the ground. So our trailer is roughly 1.3 feet tall, right? Can the boat and trailer pass under the bridge? Well, if from our trailer, so from the ground to The bottom of the boat is 1.3 plus the height of the boat, which I know is 10.8. What does that give me? Well, that tells me that, let's see, this would be 11, 12. So the height is 12.1 feet with the boat and trailer. Can I pass under this bridge? And the clearance says it's 11 feet, 8 inches. Well, definitely not, because the trailer and the boat is 12.1 feet tall. And this clearance is only 11 feet, 8 inches. Well, my boat is taller than that. So definitely, no, it can't. My boat and trailer are taller than this clearance. Okay. Hopefully that makes sense. Let me know if I can clear that up at all. All right, the last OYOs here, please pause to try 7 and 8. All right, number 7, finding the distance between those two numbers on a number line. If it helps you to draw a number line, I would suggest it. You should come up with 7.8 for the distance. And number 8, what if the clearance is 12 feet 1 inch? Can the boat and trailer pass? That is still no, it can't. 0.1, you have to make 0.1 or 10th. What's a 10th of a foot in inches? Right. Well, you have to take, if you take 0.1 times that by 12, you get 1.2. So that would be too much. So no, the boat cannot pass under still. Okay. Please let me know if you had any questions on that. Like I said before, very similar to subtracting integers. Follow those same rules, chop, chop, or add the opposite, however you want to think about it. All right, thanks for tuning in. I'll see you guys next time.